Welcome to The Explainer. Today, we are tackling a topic that, I know, it looks complicated, but I promise it's way simpler than you think. We're talking about multiplying and dividing rational expressions. And yeah, we're going to break it all down step by step. Okay, so let's just dive right in by looking at these two problems side by side. Over on the left, you've got simple fraction multiplication. You've been doing this for years, right? But on the right, yeah, that looks a whole lot more intimidating. But here's the secret, the thing you got to remember. The process for solving both of these, it's literally the exact same. And that right there is the core idea for this entire explainer. The same rules apply. Seriously. Once you get your head around the fact that these crazy-looking expressions are just fractions, everything else just kind of clicks into place. All right, first things first, let's get our key term down. What is a rational expression? Well, it's just a fancy name for a fraction where the top and the bottom, the numerator and denominator, are polynomials. You know, those things with variables and exponents like x squared plus 2x. That's it. It's not magic. It's just a fraction with slightly more complicated parts. So what's the rule for multiplying them? Well, it's exactly what you'd hope it would be. You just multiply straight across. The tops get multiplied together, and the bottoms get multiplied together. Numerator times numerator, denominator times denominator. Yep, it's as simple as that. But hold on, before you just go ahead and start multiplying everything together, which, trust me, can get super messy, super fast, we have a secret weapon. A little trick that makes everything so much easier. And that trick is factoring. This is, without a doubt, the single most important step. So you might be asking, okay, why bother? Why do we have to do this extra step of factoring everything at the start? Couldn't we just multiply straight across and then deal with the giant messy polynomial at the end? Well, here's the crucial point. Factoring first makes our calculations way easier. Think of it like this. It breaks those big, clunky polynomials down into their little building blocks. And when they're broken down like that, we can easily spot any common factors and just cancel them out. We do this before we multiply, which cleans up the problem and saves us a ton of work. Okay, you with me? Let's turn this into a super simple, repeatable process for multiplication. It really just comes down to 3 little steps. And here it is, the whole process. All you gotta remember is 3 words. Factor/multiply. That's your mantra. Step 1, factor everything you possibly can. Step 2, slash or cancel out any of the same factors you see on the top and the bottom. And finally, step 3, multiply whatever's left over. Easy, right? All right, let's put this into practice. We'll walk through an example so you can see it in action. We're gonna multiply these 2 rational expressions. And yeah, right now it looks like a beast, but don't worry, we're just gonna use our simple 3-step process. Okay, step 1, factor. We're gonna take every single one of those 4 polynomials and break them down into their simplest parts. See how that first one, the x squared plus 3x plus 2, turns into x plus 1 times x plus 2? We do that for all of them. And look at that. Suddenly the problem looks a whole lot less scary, doesn't it? And now, for the really satisfying part, the slashing. We just scan the top and bottom for any matching factors. See that x plus 1 on the top left? There's 1 on the bottom right, so gone. Same with the x minus 3s. They cancel out too. All that's left is to multiply what didn't get slashed, and there's our final, much simpler answer. So much cleaner, right? So now that you've totally mastered multiplication, guess what? Division is going to be a piece of cake. It's almost the exact same thing, just with one tiny extra step right at the very beginning. The key idea here is probably something you've heard back in middle school. Keep, change, flip. Remember that? You keep the first fraction exactly as it is. You change the division sign to a multiplication sign, and you flip the second fraction upside down. That's it. Keep, change, flip. And this is a perfect picture of what that flip does. The division problem you see on the left, poof, it's instantly turned into a multiplication problem on the right. And once you've done that one little flip, you are on familiar ground. You already know exactly what to do next. So our handy little mantra for division just gets one extra word. Instead of factor/multiply, it's now factor, flip, slash, and multiply. That flip, which you do right after you factor everything, is the only new piece of the puzzle. And honestly, that's it. That's the whole trick for division. The second you flip that fraction, the problem is no different from the multiplication ones we were just doing. You just follow the exact same steps you've already got down pat. Okay, so at this point, you might be sitting there thinking,
All right, that's a neat little math trick, but why? Why do I actually need to know this? And you know what? That's a totally fair question. So let's talk about where this skill actually takes you.
Because this isn't just some random algebra exercise that you're going to forget the second you walk out of the test. No way. This is actually a fundamental building block, a skill that is absolutely essential for higher level math. Think of this skill as a key that unlocks the door to solving much more complex equations in advanced algebra. But honestly, it's in calculus where this becomes a complete lifesaver. Being able to take a really messy expression and simplify it before you start doing calculus on it, that can be the difference between a problem that takes you 5 minutes and one that turns into a 5-page nightmare. Seriously. So what's the big takeaway here? It's this. By mastering just one simple tool, factoring, you've gained the power to take something that looks impossibly complicated and break it down into simple, manageable pieces. And that idea goes way beyond just the math problem on the page. It really makes you think, what other complex problem out there are you ready to simplify next?